time for Halloween. Hi guys. I've been playing around with a couple of LED lights and a pumpkin and a ghost figure, and what I did is I had these LED lights. There are 40 lights in there, and they are usually being powered with 3 AA batteries, but they don't need 4.5 volts, of course. And if you look inside it, you will see there's only one resistor, and the LEDs are being driven by the 4.5 volts minus the resistance, the voltage over the resistor, meaning they're getting the full power. Now let me take this back to what it is, because in fact what you're seeing here is just the original LEDs. I didn't even bother taking them apart. I can say that the blue ones are almost not being lit up, but that's not a problem, because it's the way how I did it. These LEDs would be drawing over 100 milliamps at least if I would have been using the 3 AA batteries. But I am a LiPo guy. I've got hundreds of these batteries, and well, you know them, they are 4 volts, well, round about 3.7 to 4 volts, 4.2 volts even. But how did I power these lights here? Well, I've got a very easy trick, and we've got a lot of bikes here in the Netherlands, and we are used to having these battery lights. This is just an example. It's not the same one which is driving these LEDs, but what I would like to say is I'm using the version with 2 lithium batteries, or 2 3-volt batteries in it, so it's being driven by 6 volts. Let me show you the inside PCB. This is the original PCB. All I have done is I have connected my LiPo battery, and the LED, the original LED, has been removed and is now extended via this wire, so I can connect any light source, LED source of course, I want. So, well, at this moment it's blinking. I can make it go straight, of course. The on-off switch isn't there anymore, so I'm using just any contact. I would like to have it blink again, of course. There it is. And I have been playing around with this method. The amp draw at this moment in this setup is just round about 48, well, 50 milliamps, so that's really not a lot. And that's even in non-blinking mode. In blinking mode it will be, of course, maybe half of it. And that's what makes this a useful setup. I don't need a jewel ringer or any other type. This will do the trick for me. And I've seen if I increase the load by adding more LEDs, the LEDs will be less bright, and the amp draw will go to its maximum, which is still 50 milliamps. So this is a very good LED driver. It has a lot of benefits. I also unintentionally attached this one in reverse, so the output was connected to the battery, and I didn't notice I was doing that, and the lights were going on, but I couldn't make it blink, so I reversed the wires after I saw my stupid error, and voila, the circuit is still running. It's the black dot over here. I know it's tiny, there's nothing to see here, not even, yeah, well, there with a close-up you can see there's one capacitor, there's one very small resistor there and one there, and that's it. It's really so simple, and well, these things go by for €1 or $1, £1, whatever, one money unit. All you do is remove the LED and attach your own light source to it. I even tested it on a string with 100 LEDs, and it lights up as well. It's not bright, of course, but it's with 100 LEDs, it's over 5 meters. You can light up a complete room with it. So, and that all for only 50 milliamps at 4 volts. That's 200 milliwatts. It's lovely. Well, it's all about Halloween. I know in the background there have been some pictures. I know you can't see them because it's too bright in here. So, you know what? Let's go for the last pictures with this pumpkin. Thank you for watching. Let me know what you think. Write it down below, and I'll give a reply back whenever I can. Thank you again. Bye.